Dear students, welcome back to a new mathematics session. In today's session, we shall discuss questions 16 to 21 from exercise 2.2 from the chapter Inverse Trigonometric Functions. Let's move on to the topic. Before starting the session, let's recall the domain and the range or the principal value branches of inverse trigonometric functions. First of all, sin inverse x, domain is closed interval minus 1, 1. Range is closed interval minus pi by 2, pi by 2. For cos inverse x, domain is closed interval minus 1, 1. Range is closed interval 0, pi. For cosec inverse x, domain is r minus open interval minus 1, 1. Range is closed interval minus pi by 2, pi by 2, excluding 0. For sec inverse x, domain is r minus open interval minus 1, 1. Range is closed interval 0, pi, excluding pi by 2. For tan inverse x, domain is r and range is open interval minus pi by 2, pi by 2. For cot inverse x, domain is r, range is open interval 0, pi. In the previous class, we have discussed a trick for recalling this range. For that, there is x-axis and y-axis we have to draw, and we have to mark 0, pi by 2, pi and minus pi by 2. And these are divided into 4 quadrants, first, second, third and fourth. And there are some inverse trigonometric functions whose range is coming between minus pi by 2 and pi by 2. So that is sin inverse, cosec inverse, tan inverse, but not exclusively minus pi by 2 plus pi by 2, but minus pi by 2, by using minus pi by 2 and plus pi by 2, these three inverse trigonometric functions we can write. For example, for sin inverse x, it is closed interval minus pi by 2 to pi by 2, and for cosec inverse x, excluding 0 we have to write, and for tan inverse x, open interval minus pi by 2 to pi by 2. Other three inverse trigonometric functions, the range is between 0 and pi. They are cos inverse x, sec inverse x, cot inverse x. But remember, for cos inverse x, closed interval 0, pi. For sec inverse x, we have to exclude pi by 2 from that. And for cot inverse x, open interval 0, pi. There are some other formulas also we have discussed in the last class. That is, sin inverse of minus x is minus sin inverse x. Cosec inverse of minus x is minus cosec inverse x. Tan inverse of minus x is minus tan inverse x. The other three trigonometric ratios like cos inverse, sec inverse and cot inverse x, if minus comes means cos inverse x means pi minus cos inverse x. We have to subtract from pi. And next is sec inverse of minus x is pi minus sec inverse x, and cot inverse of minus x is pi minus cot inverse x. So these are the formulas we have used in the last class, and please recall or memorize these formulas before going for the next slide. Next, let's recall the properties of inverse trigonometric functions. Sin of sin inverse x is equal to x, cos of cos inverse x is equal to x, tan of tan inverse x is equal to x, cosec of cosec inverse is equal to x, sec of sec inverse x is equal to x, finally cot of cot inverse x is equal to x. Another set, sin inverse of sin x is equal to x, cos inverse of cos x is equal to x, tan inverse of tan x is equal to x, cosec inverse of cosec x is equal to x, sec inverse of sec x is equal to x, and cot inverse of cot x is equal to x. Then in the previous class, we have discussed about the table of values of angles 0 to 90 degree, 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. We have to use this table for writing the values, and please make sure that the angles are converted into radians. Next, we have learned tan inverse x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy if xy is less than 1. Tan inverse x plus tan inverse y, one more formula is there. If xy is greater than 1 means we will use pi plus the previous formula, that is tan inverse of x plus y by 1 minus xy. Tan inverse x minus tan inverse of y, we have learned the formula tan inverse x minus y by 1 plus xy. And to tan inverse x we have formulas sin inverse 2x by 1 plus x square, Next, cos inverse 1 minus x square by 1 plus x square, then tan inverse 2x by 1 minus x square. Next, let's recall some formulas which we have learned in class 11. That is double of x and triple of x formulas. Cos 2x, there are 4 formulas: cos square x minus sin square x, 2 cos square x minus 1, 1 minus 2 sin square x, 1 minus tan square x by 1 plus tan square x. Then sin 2x is 2 cos x sin x and 2 tan x by 1 plus tan square x. Tan 2x, 2 tan x by 1 minus tan square x. And 3x formulas, triple of x formulas, that is sin 3x is 3 sin x minus 4 sin cube x, cos 3x is 4 cos cube x minus 3 cos x, tan 3x is 3 tan x minus tan cube x divided by 1 minus 3 tan square x. So these, especially these 3x formulas, that is very useful for calculating inverse trigonometric questions. So please make sure that these formulas are by hearted properly. Next, let's discuss how to derive some useful formulas which we will be using for solving inverse trigonometric functions. So we have learned sin 2 theta formula as 2 sin theta cos theta. Sin 2 theta is equal to 2 sin theta cos theta. From here, sin theta formula we are going to derive, that is, instead of theta we are substituting as theta by 2 because we want sin theta formula. So 2 we don't want. For cancelling 2, what we have to do is theta will be replaced by theta by 2, half of angle theta. So replacing theta with theta by 2. Then sin, this 2 theta will be coming as 2 into theta by 2. That is here equal to 2 sin theta. Theta will be replaced as theta by 2. Cos theta, again here also theta can be replaced as theta by 2. Here 2 and 2 cancelling time, we will get sin theta is equal to 2 sin theta by 2 cos theta by 2. So from sin 2 theta, how we are deriving sin theta? That is what we have learned. Likewise, so many different formulas we can derive from double of angle formulas. So all I am not going to discuss here, only 2 we will be discussing, and the remaining we will be by hearting. And you can try this one by replacing theta with theta by 2. So next formula we have learned as cos 2 theta. That is 1 minus 2 sin square theta. That is the formula we have learned. Here also cos theta we want. Means theta we have to replace with the theta by 2 as before. So cos into 2 theta by 2 equal to 1 minus 2 sin square. This theta can be replaced as theta by 2. Here also 2 and 2 if we cancel, we will be getting as cos theta equal to 1 minus 2 sin square theta by 2. So little more adjustment if we make, this minus 2 sin square theta by 2 we can bring to the left side, this cos theta we can bring to the right side. That means we will be getting 1 minus cos theta. This cos theta going to the right side means 1 minus cos theta is equal to this minus 2 sin square theta by 2 comes to the left side, it comes as 2 sin square theta by 2. Means the formula what we have learned is 1 minus cos theta is equal to 2 sin square theta by 2. So these are the some formulas which we are deriving from double of the angle formulas. So there are some other formulas which we are using today's calculation. They are 1 minus cos x is equal to 2 sin square x by 2. That means from here, this is the formula. 1 minus cos theta is equal to 2 sin square theta by 2. Here angle instead of theta, just x we are using. 1 minus cos x is equal to 2 sin square x by 2. Next is same way 1 plus cos x is equal to 2 cos square x by 2. Next formula, tan of x minus y is equal to tan x minus tan y divided by 1 plus tan x tan y. Next formula, tan 3x is equal to 3 tan x minus tan cube x divided by 1 minus 3 tan square x. So these are the formulas we are going to use today's calculation, and this formula also you have to keep in mind, that is sin theta is equal to 2 sin theta by 2 cos theta by 2. So you have to memorize all these formulas. Next we shall revise some more properties of inverse trigonometric functions. Here there are 3 more formulas. There is first one, sin inverse x plus cos inverse x is equal to pi by 2. Tan inverse x plus cot inverse x is equal to pi by 2. Finally, cosec inverse x plus sec inverse x is equal to pi by 2. Here you have to group as sin and cos, tan and cot, cosec and sec. Next we shall discuss the exercise problems. Find the values of each of the expressions in exercises 16 to 18. From question number 16 to 18, we will be asked to find out the values of the given expressions. Question number 16, sine inverse of sine 2 pi by 3. And when we see this question first time, we may feel to write the answer as 2 pi by 3 because it is in the form sine inverse of sine x. Sine inverse of sine x, we know that it is x. But if we use that formula here, it will be wrong because we know that the range of sine inverse is between closed interval minus pi by 2 and pi by 2. And here this is in radians. When we convert it into degrees, it comes as 180 by 2, that is 90. Closed interval minus 90 and 90, that is the range of sine inverse function. If the range comes in between these two only, we can use the formula sine inverse of sine x. So let's check this 2 pi by 3 value. When we convert 2 pi by 3 into degrees, just multiply pi as 180. So 2 into 180 by 3. Here 3 and 180 can be cancelled 60 times. So 60 into 2 is 120. So 2 pi by 3 when we convert, we have got as 120. Clearly 120 is not in between minus 90 and 90. It is out of 90. So the given value, that is 2 pi by 3, not within our range. So first of all, we have to convert these 2 pi by 3 into within this range. Then only we can apply the formula sine inverse of sine x. For that, what we have to do is, this 2 pi by 3 let's change as 120. We have converted here 2 pi by 3 into degrees. We have got as 120. Take that value and substitute here. Then this sine inverse sine 120 can be written as 180 minus 60. 180 minus 60 is 120. Now we know that sine 180 minus theta is sine theta. And we need to check here the sign also, but the sign of the result. That is, when we check the 4 quadrants, first, second, third and fourth, in first quadrant all trigonometric ratios are positive, and in the second quadrant only sine and cosec positive, and here in the third quadrant tan and cot positive, and here cos and sec only positive. And here sine 180 minus 60, this 180 minus 180 is here, 180 minus means this portion. So sine 180 minus 60 comes here, sine 120 comes here. That means it is in the second quadrant. In the second quadrant, sine and cosec positive. That means sine 180 minus 60 is a positive value. So we can write as sine 180 minus theta as sine theta. That is sine 60 is the answer, and the sine is positive itself. That means sine inverse of sine the angle, that is 60 degrees. Sine inverse of sine 60 we have written. And here sine 60 is positive because it comes in the second quadrant, 180 minus 60. Then now this 60 degree, that is within this range, minus 90 and plus 90. So we can apply the formula sine inverse of sine x. Sine inverse of sine x is x, that is here 60 degrees. Now this 60 degrees, 60 is in degrees, we have to convert this one into radians. Just multiply pi by 180. So 60 into pi by 180. Here 60 and 180 can be cancelled 3 times, and we will be getting as pi by 3. So that is the answer, pi by 3. Next, question number 17, tan inverse of tan 3 pi by 4. Here also at a stretch we cannot use the formula tan inverse of tan x because this 3 pi by 4 is not within our range. So first of all, we need to change this 3 pi by 4 as our convenient range. That is, we know that the range of tan inverse is open interval minus pi by 2 and pi by 2. When we convert this one into degrees, it comes as minus 90 and plus 90. And let's check this 3 pi by 4. What is the value? 3 pi by 4 means 3 into 180 by 4. And when we do the calculation, we will be getting as 135. 45 into 3 is 135. Clearly 135 is not belongs to minus 90 and plus 90 open interval. So we need to change this one. As before, let's write this one into degrees. That is tan inverse of tan 135. 3 pi by 4 we will be getting as 135. And this 135 as before we can write it as tan inverse of tan 180 minus 45. 180 minus 45 is 135. Here also we can use the formula tan 180 minus theta. Tan 180 minus theta is tan theta. And we need to check the sign. 190 minus 45, that is 190 minus is here, 135 is here in the second quadrant. As before, in the second quadrant only sine and cosec is positive, all other trigonometric ratios are negative. Means we will be getting here the result as negative. So we are getting the answer tan inverse of tan minus 45. So tan 180 minus 45 is tan minus 45. Here minus sign is coming because it is in the second quadrant. Now it is clear that this minus 45 is between minus 90 and plus 90 within our range. So we can use the formula tan inverse of tan x. Tan inverse of tan x is tan x, that is x itself, that is minus 45. Now we can change this minus 45 into radians, just multiply pi by 190. And 45 and 190 when we cancel we will be getting 4 times. So I will be getting the final answer as minus pi by 4. Move on to question number 18. The question is tan of sine inverse 3 by 5 plus cot inverse 3 by 2. We are asked to find out the value of this expression, tan of sine inverse 3 by 5 plus cot inverse 3 by 2. So when we see this question, when we observe this one, this is in the format tan of a plus b. So this we can consider as a and this we can consider as b. Then we will be getting as tan of a plus b. Then by using tan a plus b formula, we can solve this expression. So first of all, let's take this one as a and this one as b. That is, put a is equal to sine inverse of 3 by 5. Now sine inverse 3 by 5, we just take this sine to the left side, sine inverse to the left side. We'll be getting a sine a is equal to 3 by 5. Sine a is equal to 3 by 5 means sine a formula we know, trigonometric ratio, that is opposite side by hypotenuse. Means when we consider a right angle triangle ABC, and here this is our angle A, and these two B and C we can make, and here we are fixing the angle because that is our required angle, sine A. Sine A is O by H. With respect to this angle A, O is this one, opposite side is BC, and hypotenuse is this one. So that means here the opposite side is 3, and hypotenuse is H, that is AC is 5. So here there is one more side is missing, that is AB. So by using Pythagoras theorem, let's find out the value of or the length of the side AB. Pythagoras theorem, we know that it is h square is equal to a square plus b square. Means hypotenuse square is the sum of the squares of other two sides. Means if you want to calculate AB, we'll be getting as a root of the other two sides square, subtract. That means highest length is this one, the longest side is hypotenuse, that is 5, and another side is 3. So 5 square minus 3 square, root of 5 square minus 3 square. If you don't know Pythagoras theorem, let's recall it, just recall it before solving this question. Pythagoras theorem, once again I will tell, that is hypotenuse square, that is AC square is equal to AB square plus BC square. If you want to calculate AC square or AC, if you want to calculate root of squares of other two sides sum. Any other two side, if you want to calculate root of hypotenuse square minus the given side. That is what here AB is the required side, and the longest side is 5. So 5 square minus 3 square, square root is AB. Then when we calculate 5 square is 25, 3 square is 9, 25 minus 9 is 16, root of 16, answer is 4. So we have got AB as 4. Then the another part, that is cot inverse of 3 by 2, that we will be considering as B. B is equal to cot inverse 3 by 2. Take this cot inverse to the left side, that is cot B is equal to 3 by 2. Cot B formula we know, that is adjacent by opposite. Adjacent by opposite is 3 by 2. Again we will take a right angle triangle and our angle is B, and A and C we can put as you wish. Here I am fixing B angle, and B, with respect to this B, opposite is AC and adjacent is AB, hypotenuse is BC. So A by O, A is here, that is AB, and O is this one, AC. AC we are having 2, just marked. Then we will be going for substituting here the values. This one we have replaced as A and this one we have replaced as B. So the given expression will be coming as tan A plus B. So tan A plus B is equal to, we know the formula, tan A plus tan B by 1 minus tan A tan B. And here tan A tan B we are having. So we need the values for substitution here. So tan A we can calculate with respect to this angle A. Tan A is O by A. O by A means O is 3 and A is 4. With respect to this A angle, O is BC, that is 3. Adjacent is AB, that is 4. So 3 by 4 we have got. And another one is tan B we need. So B means this is our angle. So from here we can calculate tan B. Tan B also formula is O by A, that is 2 by 3. This is O and this is 3. Sorry, this is A with respect to this B angle. So O by A is 2 by 3 we have got. So all the values we are having now, just substitute. That is tan A is 3 by 4, tan B is 2 by 3. So 3 by 4 plus 2 by 3 divided by 1 minus 3 by 4 into 2 by 3. And here we'll go for normal calculation. 4 into 3 LCM if you take, 3 into 3 9 plus 4 into 2 8, that is in the numerator. And denominator also 4 and 3 we can take LCM. 4 into 3 if you take LCM. 4 into 3 into 1. So 4 into 3 into 1 is 4 into 3 minus, here nothing to multiply, that is 3 into 2 itself. Then we'll be getting as 3 into 3 9, 2 into 4 8. And here 4 into 3 12, 3 into 2 6. This can be cancelled. Either you cancel here itself or else you can wait. Then here we can cancel both. So both we have cancelled, and 9 plus 8 we are having 17. 12 minus 6, final answer 6. So the answer is 17 divided by 6. So remember how we have to solve this expression. This is in the format of tan A plus B. So we are assuming this as A and this one as B. Then by using normal trigonometric calculations, we are calculating the required trigonometric values, that is tan A, tan B and all. Next we shall discuss question number 19. Cos inverse of cos 7 pi by 6 is equal to, there are 4 options. 7 pi by 6 first option, 5 pi by 6 second option, 5 by 3 third option, and pi by 6 fourth option. We have to choose the correct or appropriate answer from the given options. So this one is quite familiar for us. Previously we have discussed this type of question. So let's take cos inverse of cos 7 pi by 6. And this we cannot use the formula cos inverse of cos x because 7 pi by 6 is out of our range. So let's bring this one into inside our range, that is range of cos inverse is closed interval 0 to pi, 0 comma pi. And let's check this, just write this one into degrees, that is 0 comma pi value is 180. And here 7 pi by 6 we have to take and we have to convert it into degrees. 7 pi by 6 is 7 into 180 by 6. 6 and 180 will be cancelled and getting 30. 7 into 30 is 210. So 210 clearly out of this range, that is 210 is not an element of closed interval 0 180. So we are going to change this one into our required format. So this 7 pi by 6 will be converting, or we will be replacing and writing as 210. That is cos inverse of cos 210. And this 210 we can write as 180 plus 30. 180 plus 30 is 210. So cos inverse of cos 180 plus 30. And cos 180 plus theta is cos theta. So we have to check the sign convention, that is 180 plus 30, that is 210. 210 is clearly in the third quadrant. Third quadrant, here all trigonometric ratios are positive. Here sin and cosec, then here tan and quarterly positive. But here our cos is in third quadrant, means it is negative. So we will be getting the answer as cos inverse of minus cos 30. Cos inverse of minus cos 30. And this is in the format cos inverse of minus x. We know that cos inverse of minus x formula, pi minus cos inverse x. We have learned in the beginning of this chapter. Cos inverse of minus x is pi minus cos inverse x. Here instead of x we are having cos 30. So we will be writing as pi minus cos inverse x, that is cos inverse, our x is cos 30. So pi minus cos inverse of cos 30. Please remember or be careful when you convert this one into, or when we use formula here. That is cos inverse of minus x format. Cos inverse of minus x is pi minus cos inverse x, that is our formula. Here our x is cos 30. So pi minus cos inverse x, that is x is cos 30. Then that is equal to pi minus this 30 clearly within our range. So with our range is 0, 180. So this 30 is within our range. So we can use the formula cos inverse of cos x, that is x. So cos inverse of cos 30 is 30. So pi minus 30 we have got. Now we have to convert this one into our radian format, that is pi minus 30 is pi by 6. And when we take LCM here, 6 into pi, that is 6 pi minus pi, that is equal to 5 pi by 6. 6 into pi is 6 pi minus, there is a pi here, 6 pi minus 1 pi is 5 pi, 5 pi by 6. So 5 pi by 6 is our B option. So correct answer is B. There are two more questions remaining in this exercise, that is question number 20. Sine of pi by 3 minus sine inverse of minus 1 by 2 is equal to, there are four options, 1 by 2, 1 by 3, 1 by 4 and 1. And question number 21, that is tan inverse of root 3 minus cot inverse of minus root 3 is equal to, again four options, pi minus pi by 2, 0, 2 pi by 2 root 3. So these two questions you will try it as homework. Dear students, today we have discussed question number 16 to 21 from exercise 2.2, and also we have completed second exercise from the chapter inverse trigonometric functions. I request all the students to go through first exercise and second exercise questions, and while solving, if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.